Hello, second grade Cougars. It's Mrs. Bellatash, and I want to do a quick little review of the order of the rocks. So there's a boulder, which is as big as a basketball or anything bigger than that. There's a cobble, which goes from a size of a grapefruit to a boulder. There's a pebble, which goes from something small like this to the size of a grapefruit. There's gravel that goes from tiny little pieces up to a pebble, sand, silt, and finally we are at clay. We are going to take a look at some clay today. Last time we finished by putting some sand in vials and adding water and shaking it up. And I let it sit for about 2 hours, and we saw the sand fall down to the bottom. We saw clay or some type of a silt material, something smaller than sand, in the water above. And then over time, the water has gotten clearer and clearer because all of the little bits of earth material have settled out. But there are some little bits at the top. Those are organic matter. That's humus, and we're going to learn more about that later. But now that the silt and the sand have completely settled out of the water, we can clearly see that there is sand and that there's something else that was part of the soil, something that was smaller than sand. And the thing that is smaller than sand is silt. Now we're going to start looking at something even smaller than silt and a little different from silt, and that is clay. Okay, so boys and girls, you should have a bag that has some clay in it. And if your clay was a little hard, I ask your teacher to tell you to put in maybe half a spoon of water into your bag and let it sit overnight. If you didn't do that and it's still a little hard, you might want to dip it a little bit into just a little bit of water, and it'll help soften it up. I'm going to take a little ball of this clay and I'm going to put it into one vial, and I'm going to take another ball of clay and I'm going to put it into another vial, and now I'm going to add some water to this vial. And this vial, I'm not going to shake. I'm going to leave it just like this. Now, I'm going to take my second vial and I'm going to add water. And this time, I am going to shake it. So let's take a look at both of them right now. This is the two things of clay. And this one I'm going to shake. Okay, now I have my two vials. Now, this one I did not shake, and I'm going to let it sit overnight, and we're going to see if anything happens to this vial. This vial, I shook it up, and you can see that now the water is kind of cloudy, but you can still see that there is a clump of clay in the bottom. You see that little ball? Now, if this had been silt, the silt is not sticky. And so all of the silt would have been suspended in the water. There would not be a ball of silt that sits at the bottom. And this is the thing that's different about clay. Clay is sticky. Over time, water interacts with the silt and the sand and kind of chemically weathers it and makes it turn into clay, which is a sticky earth material. One of the awesome things about clay is that it is sticky. If I had a handful of sand and I tried to hold onto it like this, it would just fall right through my fingers, right? If I had a handful of pebbles, gravel, they could slip through. But clay is sticky. It keeps itself together because of the moisture. Now, I'm gonna make a little something with this. I'm gonna maybe make a little pinch pot. Have you ever made a pinch pot? You take your clay, you make a little ball. You can use your hands to add force, right, and create a shape. And then I'm gonna put my finger in the center, and I'm gonna make a little, and I'm gonna pinch it around, and I'm gonna make a little pinch pot. You guys can make anything else that you would like to do. Use your little bit of clay and make something. This is something that's awesome about clay. It sticks together. Oh, look at my nice little pinch pot. See what I did? And I can, if I wanted to, I could take a pencil and I could make a design on the outside. Clay is awesome because you can make things out of it. And if you added clay to some other material, some other earth materials, the clay would help those materials stick together. Now, because clay is sticky, it's full of water. If we leave it out like this and just let it dry, it'll get hard. But unless we put it in a kiln and fire it, what we could do is when we get tired of it, just put it in a little water and it'll turn back into soft, sticky clay again. Clay, it's awesome. It is the next day and here's my pinch pot. Yesterday, remember, it was soft and pliable, but now the water that was in the clay has evaporated and it turned it from like a nice soft material to something that's hard, right? So we changed the properties of the clay by letting the water evaporate. Now let's think back to our last unit. This is a reversible change because I can put this in water and it will get soft again. If I put this in a kiln and bake it and drive out all of the water, and when I bake it, there's a chemical change in the clay, then it is an irreversible change. But right now, I didn't bake it, I just let it dry, and this is a reversible change. Now, let's take a look at the little balls of clay that's in the vial. Remember yesterday, I made the little balls of clay and put them in the water. This one, I did not shake. This one, I shook. And the one that is the ball of clay that I put in the water, because clay is sticky, it is still a ball of clay. If that was silt, it would have just fallen all to the ground, to the bottom of the vial. But because clay is sticky, it is sticking together in a ball in the water. Here's the one that I shook up. Now, because I shook it up, the water was able to loosen some of the outer pieces of clay on the outside of the ball. But the rest of the clay has not loosened. The rest of the clay is still a ball. And you can see the very, very fine clay particles in the bottom of the vial. Second graders, get your science notebook out, and I want you to glue 2 pages into your science notebook. The first one, it says clay and water drawing, so glue that one in. And on the next page, you're going to glue in rocks in bottle drawing. Okay, so number 1, it says, what earth material is smaller than silt? Well, we know it is clay. Draw what you see in the vial. And this is the vial that we're talking about. Here's the ball of clay and the water. So draw what you see in the vial. What I did is I drew a line here and I said that's the water level, and then I just drew the little ball of clay because the clay did not fall apart because it is sticky. Okay, the vial has water and a ball of clay. Now let's turn to the next page. Rocks in bottles. A student used rocks of different sizes to make layers in the bottle with water. Label the layers in the bottle drawing. So, at the bottom are pebbles. The next layer is gravel. The next layer is sand, then silt, then clay, and then water is on top. Now, one of the things that's interesting about if you wanted to actually do that experiment, if you put all those materials in the water, just mix them up, and then put the water on top and shake, 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 what happens is that the pebbles, the gravel, the sand, the silt come out in layers just like that. The reason is because the heaviest rocks fall out of the water first. Which rocks are heavier, pebbles or sand? Pebbles, because they're bigger. They fall out of the water first. So it goes pebbles, gravel, sand, silt, clay. And the smaller the rock is, the longer it stays suspended in the water. Have a wonderful winter break, everybody. I will be missing you, but I'm going to be looking at rocks and continuing to collect rocks. Maybe you can collect some rocks too. All right, I'll see you next time.